Welcome everyone. This is security in the JavaScript ecosystem. And today I'd like to start with a story. And this story is about Alex, who, like most of us here, is a developer. And through the magic of open office plans, she overhears that annoying guy from accounting bragging about how they made a bunch of money when they bought into Bitcoin early. And now Alex knows it's too late to get in on the economic front. He knows that the technology behind this, and yeah, but he doesn't have any interest in participating in the economics. But he does know one thing. If Alex can get a hold of the private key, all those coins could be his. So he starts to hatch a plan. And he knows that most cryptocurrency software is open source. And they're very welcoming, and they'd like to have contributions. So Alex starts looking at the Bitcoin core client and trying to figure out how they can sneak in some code to steal all the Bitcoins. But as it turns out, there's a lot of eyeballs on this project. And to be fair, Alex is not quite confident that they would manage to, for example, exploit a buffer overflow they would introduce. So instead, they choose a different target. As it turns out, there are many different cryptocurrency wallets out there. And some of them are written in JavaScript. And Alex knows that within the JavaScript world, where everyone uses the NPM repository, it's very common to just pull in dependencies left and right and to speed up your development that way. However, they also know that some of these dependencies may have a lot less eyeballs on them. So instead of putting on their black hat, Alex goes and helps. They pick a mark, a somewhat well-used cryptocurrency wallet, and they look at all the dependencies. And they pick a couple and they just start contributing to these packages. And at some point, the maintainer of one of these packages says, hey, I've moved on to other projects. I don't want to maintain this anymore. Maybe you would like to maintain it for me. You've done some great contributions in the past weeks. Do you want to take over? And Alex goes, jackpot, I'm in. So what Alex does is an updated version is published, which checks, oh, is this in the production environment, and does the package we're currently in match the wallet that I'm trying to breach? And if yes, they just post the private key of the wallet to a server that Alex controls. So they wrap this in several layers of obfuscation, and it turns out they did a good job, because by the time the community has figured out what Alex has done, multiple versions of a vulnerable wallet have been released. My name is Pim Otte. I'm a software developer at Quintor, and this story scares me. Not because it could happen, but because it actually did. Now, before I dive into what are the attack vectors when you use packaging systems and how we can defend, I'd like to say that I really like package systems. They help us a lot. It allows developers not to reinvent the wheel over and over again. It gives a tremendous boost to open source development. But you have to be careful. When you pull in dependencies willy-nilly, you can get bitten. And this actually happened with the event stream package. The event stream package was the package that Alex targeted, and using this dependency, they caused a Copay Bitcoin wallet to release multiple vulnerable versions. We don't know how many Bitcoins Alex obtained, if any, but we know that they got really, really far. So in this attack, you simply show up as a friendly maintainer and you try to get publishing rights to a package that is already popular or at least used in a target that you're trying to inject code into. Second thing that can happen, developer or CI continuous integration accounts can get compromised. This happened to eslint-scope. One of the developers, their account got breached, and a malicious version of a package was uploaded which stole credentials of developers. So this was an attack really targeted towards developers. And if you've written some JavaScript, you recognize the name eslint. This is basically half the ecosystem lints using this underlying tool. So another attack vector is typo squatting. This is by no means unique to the NPM ecosystem. The most famous example here is crossenv. This is the typoed version. The actual package has a dash in between. There's also been someone who did this with pip for Python, and they published statistics on how many times people typoed certain names. And this is still an attack vector that's quite doable, and it simply urges caution on the developer. So what could also happen is that the maintainer joins the dark side, and I see this most commonly in Chrome extensions, where the maintainer just sells off the entire extension to a company, which then puts in telemetrics or worse. I've also put leftpad here. It's a little bit unfair to the maintainer of leftpad. What happened here was there was a dispute about naming of another package, and the maintainer of leftpad pulled all their packages in response. And why leftpad is the one that's special is because it was a transitive dependency of a lot of projects, amongst other Babel. So CI builds across the world were failing because he pulled this package. And lastly, people tend to forget this, but the package server itself can get compromised. As far as I know, this hasn't happened with NPM, but it has happened with the Ruby gems server, where you could upload a malicious gem and it would gain remote code execution abilities on the server where the packages were served from itself. It was sort of a demonstration attack in which only database credentials had been breached, but it could have been a lot worse. So now we know about these attack vectors. So the question is, how are we going to defend? And we can defend ourselves for a large part by asking three questions. Firstly, are you secure? This means your developers, this means your infrastructure, but this also means the developers and the infrastructure of your dependencies. There are very simple measures that you can already take right now to ensure that you are secure. Use strong passwords, two-factor authentication. Second question is, what are you running? Which dependencies are you pulling in? Why are you pulling them in? It doesn't make sense to do so. Have you looked at the code? Do you have faith that this is actually quality code? And lastly, did no one tamper? Did the code, as you looked at it, actually get into your project as you wanted it to? So let's look at each of these questions. So are you secure? What does this mean? It means use strong passwords. This should be a no-brainer. If you don't have a perfect memory, use a password manager. I like Bitwarden a lot, but there are plenty of others out there that do the job just fine. Secondly, enable two-factor authentication. NPM and GitHub offer this. A lot of other package services offer this as well. Sometimes you can even, within an organization, force to enable two-factor for all your users. If you can, you should do so. And these two combined get a lot of the breaches out of the way that come through this factor of if your accounts are actually secure. Secondly, what are you running? And with respect to what you're running, there's a very simple thing you should be doing already, and if not, you can start today. It's npm audit. npm audit looks at advisories that are published about packages, and it checks, are any of your transitive dependencies vulnerable in a way that we already know. Run this regularly, and you'll know if there's public information out there that tells you, hey, you might have a problem. Second part, code review. And here it starts with actually looking at the code. So if you pull in the dependency, you should have looked at the code, even if it's just for a little bit. Judge the GitHub repo. Are there open pull requests? Does it seem stale? These are all factors that should influence whether you decide to pull in a dependency or not. What I'd like to look at in the future is to actually collectively start reviewing code. And the tool I've put up here is one that works for the Rust community. So they have this cref tool, and you can review crates, what they call packages, and then publish what you think about them and trust other users for their reviews. This is still in progress, but I would really like to have this for the NPM ecosystem as well. So last question, did no one tamper? There's a fairly common way of dealing with this. It's signing. Sign your packages and verify the signature. This is most commonly done by using PGP. Lately there have been denial of service attacks against key servers, so there's a little bit of a weakness there. If anyone knows a better way to sign packages, I'd be happy to hear about it, but I couldn't find any. For now, PGP seems to be the gold standard. For this to work in the NPM ecosystem, we would actually need tooling that verifies these signatures automatically and signals, hey, this package is not signed or used to be signed and is no longer. This is also why I'm more comfortable pulling in, for example, Java dependencies from Maven Central. They enforce signatures. And this is a small step, but it's an important one to me. And lastly, reproducibility. This is often talked about in the context of having a Java or having source files and compiling it into a binary. But in the case of JavaScript, the packages published are often minified code, which is very efficient, but not very readable. So if you pull in this minified code, you need to know, is the source code that I looked at the same as the minified result that I'm actually using? In order to do that, this is a very work-in-progress tool as well. It simply gets the sources from GitHub with the corresponding tag and tries to run npm pack. And if that works and the pack, the tarball that results is the same, then you've reproduced your package. These were my tips. Thank you for your attention. If you want to check out the slides, they're available online. Quinter builds quality software for our customers. If you want to help us, let us know. And I also want to give one final recommendation. If you missed his talk this morning, Cedric Champeau's talk was very good. It approached the topic more from a Gradle and actually to a lot deeper than I've been able to go into this 15 minutes. So if you missed this, I highly recommend you go and watch it back. Thank you.